Hi everyone, so here in this video I'm going to go ahead and kind of quickly go through simplifying radicals and solving some simple quadratics. So we have a radical here, it's a square root. Okay, so what we're going to do with our square roots is we have to simplify it here. So I'm going to go ahead and do factor tree. So 3 times 21 will get us 63. 3 times 7 will get us 21. As you see here, you have a pair of 3's. The 3's come on out of the radical and we have a 7 left over. So radical is simplified. Another way to think about it is when we go ahead and get these factors 3, 3, and 7, we're going to have 3 times 7. From here, that's a 3 squared times 7. The square root and the squared cancel. That's why we get the 3 on the outside and the 7 left inside. Okay, so that's just another method to do it. The next one here, we're going to go ahead. The square root of 525 reduces down to 25 and 21. From here to get 25, 5 times 5, that's a pair. So the 5 comes out, and then we're left with 21. The next example we have here, I'm going to go ahead and do this in one method, and then so number 3 I'll do one way, and number 4 I'll do another to show the two different ways you could do this. So here, because it's squared, that means we have 3 square root 3 two times. So let me fix this here. So 3 square root 3 times 3 square root 3. So I'm going to multiply the 3's, so we're going to get a 9 times the square root of 3 times 3 underneath the same radical. From here, we have 9. Square root of 3 times 3 would be the square root of 9, which the square root of 9 is a perfect square. So we'll get 3. So then in the end, 9 times 3 will get 27. All right, the next way I'm going to do it is instead of going and breaking it down, I'm going to kind of think of this as like distributing that squared. Okay, because it's essentially the same thing. So it's going to be 3 squared times the square root of 2 squared. What's going to happen is we're going to have a 9 here, and when you square a square root, that actually cancels out because they are inverses of each other, and we're just going to get 18 as our answer. Okay, so you can do either way for 3 or 4, whichever you're comfortable with. All right, the next one, number 7, this is actually supposed to be a multiplication symbol here. So in this one here for number 7, we're going to go ahead, multiply the 2 and the 3. So 2 times 3, 2 times 3, we're going to go ahead and get 6. Square root of 5 times 15. 6 square root, 5 times 15 is 75. We're going to go ahead and now do a factor tree here. Well, actually, so I went ahead and I multiplied them, and you can get 25 here and 3, and then get 5 and 5. Now, that's one way of doing it. You could have also gone ahead and said, okay, well, wait a second. I know how to get 15. You do 3 times 5. Well, then now you have a pair. But if it's a little easier to think of it the other way, where I multiplied the 5 and 15 to get the 75, just to kind of simplify things a little further to then simplify again, whatever method is fine and easier for you. So then 6 times 5 and then 3. So whatever you take out here is multiplied to the outside. So then we're going to end up with a 30 square root 3. All right, the next one here, wherever it went, here we have a 2 on the outside, but underneath this radical here, we can absolutely simplify this. So I'm going to simplify all that's in here. So 96, we can get that by doing 6 times 16. This simplifies to 3 times 2. 16, we can do 2 times 8. 8 is 2 times 4, and 2 and 2. So we have a pair of 2's, then we have a 3 and a 2 left over. Over here in the x, to get x squared is x times x. So taking a look here, that's another pair we're going to take out. So everything I have circled here has a pair. All the pairs come out of the radical. So 2 times 2 times 2. Okay, so I have this 2, this 2, this 2, and then I'm going to include the x's. So then here we have x, square root. The leftovers stay inside, so it's just 2 times 3. So from here, we're going to go ahead and simplify. So 2 times 2 is 4, times 2 is 8x, square root 6. Moving on to the next. So over here, this one, these examples we need to rationalize. So to rationalize, that means we are going to have to multiply by the denominator to get that out of there. It's kind of like if we were trying to get a common denominator when adding and subtracting fractions. So I'm going to multiply this here by the square root of 3 over the square root of 3. What that's going to do is take a look here. We're going to get the square root of 3 on top because that times 1 is just the same thing. Here we're going to get the square root of 3 times 3. To simplify further, we'll get the square root of 9, which the square root of 9 is actually just 3. So then our goal is to get the radical out of the denominator, and we have done that here. So then the next one, same exact process. I'm going to do this one in a little less steps. So I'm going to multiply by the square root of 2 over square root of 2. From here, we get 3 square root 2. Square root of 2 times the square root of 2 will give us the square root of 4. And so you notice how I skipped that step here. I skipped this in between step here. You don't necessarily need it unless you want it to have it. So then here's 3 square root 2 over 2. As you can tell, the square root of 4, of course, is a perfect square, so you get a 2. And honestly, your goal is to get a perfect square in the denominator to be able to get rid of the radical. Alright, the next one here, this one, we're going to go ahead and do the same thing. So taking a look, we're going to multiply by the square root of 2 over the square root of 2. Here we'll have 2 square root 15 times 2, since they're both underneath the radical, we're going to get a 30 over the square root of 4, which will get 2 square root of 30 over 2. But now hold the phone, we have a 2 and a 2, those divide out, so we'll end up with just the square root of 30. Alright, next one. This one here is a tricky one. So we are going to be multiplying by the conjugate, which is essentially the opposite. Okay, remember our goal is to get a perfect square down the bottom and be able to kind of get rid of that radical. So to do that, we are going to multiply by the conjugate, which is when you do 1 minus the square root of 2 over 1 minus the square root of 2. Notice here how this is a plus and this is a minus. You have to multiply by the opposite. So then here, we'll get a 2 times 1 minus the square root of 2. Right, I'm just copying everything over. I'm not changing anything yet. 1 plus the square root of 2 times 1 minus the square root of 2. Now notice, I literally did not change anything yet. I just rewrote it to the side. Now I'm going to go ahead and distribute everything. And then I'm going to distribute here and then under as well. Alright, so our numerator, we are going to get 2 minus 2 root 2 over 1 times 1, we get 1. 1 times negative square root 2, square root 2 times 1, positive, and that's going to be a negative square root of 4. Now let's go ahead and simplify further. I'm going to keep this up here, 2 minus 2 root 2 over 1. These actually cancel because it's the opposites of each other, so they subtract out. Minus the square root of 4 is actually 2. So we can simplify here 2 minus 2 root 2 over negative 1. Because of that negative, we can actually just change the signs of all the ones in front, so it'll become a negative 2 plus 2 root 2 as our final answer. And again, the big thing is multiplying by the conjugate, which is that opposite in the middle there. Now here, these last two examples, we're just going to go ahead and practice some solving with our radicals. So I'm going to divide both sides by 12 to get rid of that out front. So we'll have x squared equals 1/2 when we reduce. Take the square root. Remember, when you have an equation and you're taking the square root, you get a plus or minus. So x equals plus or minus the square root of 1 over the square root of 2. And I wrote it this way on purpose because take a look, our denominator is a radical. We need to get rid of that. So over here, we'll have, again, plus or minus square root of 2, and the square root of 1 times the square root of 2 is just the square root of 2, over the square root of 4, which essentially will just be plus or minus square root 2 over 2 is our final answer. Next, over here in this one, I'm going to do the same thing. I'm going to divide by 4. Those cancel. We're going to get 2x plus 1 squared equals 25 over 4. Now I'm going to go ahead and get rid of this radical. So I'm going to go and take the square root to both sides here. That cancels out the squared. We are left with 2x plus 1 equals, plus or minus 5 over 2 because those are both perfect squares. Then from here, I'm going to go ahead and solve. Now, if it helps, there's two things that you can do, and I'll actually get rid of this parenthesis here. There's two things that you could do. I'm going to just continue this one by going by 2x equals minus 1 plus or minus 5 over 2. Divide by 2 to both sides. X equals negative 1 plus or minus 5 over 2 divided by 2. And then from here you can simplify, putting this into your calculator, doing it by hand. But remember, you have a plus and a minus. Okay, you have the plus and the minus. Now, you also could go ahead and say, okay, well, I'm just going to do this step into 2. I'm going to have 2x plus 1 equals 5 over 2. And we will have 2x plus 1 equals negative 5 over 2, and then solve from there. Either one is fine. We will end up getting our answer to be negative 7 over 4 and 3 over 4. All right, if you have any questions, just let me know.